underscore base socket private byte buffer equals new byte 8 kilobytes private connect callback underscore connect callback private dictionary int transfer queue transfers equals new dictionary of int and transfer queue. Now let's make a couple of properties. Public dictionary int transfer queue transfers get return underscore transfers. Public bool close get private set. Public string output folder get set and public IP endpoint get private set. So let's review what we have so far. We have our base socket, of course, our buffer, of course, and connect callback. So when we call begin connect with our socket, we will use this to let the form know that the connection was successful or wasn't successful. This will hold our transfers. This will be so we know if this class was closed or not. This will be our output folder where we will save our transfer files, and this is just the endpoint of the connect client. Now let's make our events. Public event transfer event handler queued public event transfer event handler progress changed public event transfer event handler stopped public event transfer event handler complete and public event handler disconnected. Okay, now let's make our constructors. Public transfer client. This will be the client side of it. If we create a client, if we want to connect to the server, base socket equals new socket, address family .internetwork, socket type .stream, and protocol type TCP. This constructor will be for the server mainly. Socket sock underscore base socket equals socket equals the socket, and endpoint equals cast to IP endpoint underscore base socket dot remote endpoint. So with our listener, when the socket is actually connected, we will pass it to here, and then it will set the socket, and then it will grab the endpoint. We will use this constructor when we create our client and we want to connect to the servers. Which is why we only create the socket and we don't grab the endpoint, because we're not connected yet. Now let's make our connect method. And connect callback. Underscore connect callback equals callback, and underscore base socket dot begin connect. Hostname, port, our connect callback, and the state is our callback. Actually, we don't need that. Our state is null. Private void connect callback async result AR. Try catch string error equals null underscore base socket dot in connect AR endpoint equals IP endpoint underscore base socket dot remote endpoint and catch exception ex error equals ex dot message. And now we will call our connect callback. This and our error. So now going back up here, when we call connect from our main form, we will pass a callback, and then when we call, and then we'll set our callback to our variable, and then when we call begin connect, we set our actual begin connect callback here, and then after that we'll have our try catch because .NET throws an error if it can't connect. We'll call in connect. If it's successful, then we can get our endpoint. If not, we'll set the error, and then we'll call our callback. Now, in our main class, we'll check and see if error is null. If error is null, that means the connection was successful. If it's not null, then there was an error, and then we'll display it. So now we have the client part set up. We have the client and the server part set up, actually. Now, let's do the stuff that's going to go back and forth. The mutual things. Public void run. This will just call begin receive. So underscore base socket dot begin receive buffer 0 buffer dot length socket flags dot peak null and null. Let's head down here and let's make our callbacks. Private void receive callback async result AR, and let's just set this here before we forget. Okay, so far you guys have basically seen this, except now instead of using socket flags.no, we're using peak. Now the reason why we're using peak is so we can check and see how many bytes we actually have available, because data might get fragmented, which is why in one tutorial some of you guys were getting negative 2 million or positive 4 million or something like that, because 2 bytes were in the buffer but the other 2 bytes kind of lagged behind. So we read the data and we only had 2 bytes, and if a number's off, then who knows what you're gonna get. So we're gonna call peak, and then we'll check and see if there's at least 4 bytes available, so we know our size buffer is there, and then we read it, and then we'll continue on, and so on and so on. And now let's head down to our receive callback, and let's add a try catch. And int found equals underscore base socket dot end receive AR if found greater than equals 4. The size of an integer is 4 bytes. Underscore base socket dot receive buffer 0 4 and socket flags dot none. Now we actually received our size buffer. Int size equals bit converter dot to int 32 underscore buffer 0 int red equals underscore base socket dot receive underscore buffer 0 size and socket flags dot none. Now even here, data could still be fragmented. So we'll check and see if our red size is the actual size, while red less than size. If they're the same size, then this will be ignored.